Hello, welcome to my channel. Right now, this is not a math video, but this is a really cool engineering system. It's a way to architect a solution. And I'm not talking architecture like you're gonna build a house. Here, you're gonna build a complex system. Like when you build a skyscraper, it's a very complex system. Skyscraper is very tall. But also, when you build an airplane, it's a complex system. When you build a ship, complex system, a space system, everything's complex. And this tool is it's really good because you use an overview. You also use other systems things and engineering methods, but this is a tool that is standardized for engineers to communicate with each other. This tool was introduced to me by my friend, and he's a really good friend, Sergio Luna, and Dr. Anna Cram was the one that taught me about this. And my friends Roger Hawkins and Dr. Smith were the ones that introduced me to systems architecture. And I also I can't leave out the people at Dassault Systems, the people that work with this CATIA and Magic and the Magic Systems of Systems Architect, because I do interact with them over the internet, especially LinkedIn, and I also look at their papers in IEEE and in COSI, and they're marvelous people, and I love the way that they document it. But I gotta show you this system because it is a magnificent system. If you've ever been introduced to flowcharts, this is like a flowchart, but on steroids that is on top of steroids that is on top of steroids. To appreciate it, let me show you one way that we all know how to architect. Let's use a basic notepad, and here we'll just we'll say that we are talking about space. So space, we could just call it a Earth orbit, right? So you have to let me write it again with my pen. So here, let's say that we want to talk about Earth orbits, right? So we would get our pencil, right. I'm gonna use the UML style use cases. So we would put basically the Earth orbits, right? And then you would it looks more like a, what is it, like a brainstorming diagram. Then you could say, okay, who's on Earth orbits? You got the ASAT systems. That's anti-satellite, the ones that are trying to kill satellites and orbital weapons. Then you got like your rockets or the payloads that are headed to deep space. We'll say the space vehicles, right? But you have to write it. Look at how ugly my writing is. Space vehicles. And there's no standard. We could be using triangles or whatever. Let's say we got satellites. What else is out there? Space debris. That's the leftover stuff from anti-satellite weapons, or when they crash in space, or stuff that people don't pick up. We'll also put the moon in there. We should not put the moon because the moon isn't it wasn't engineered. It was made by God. But we'll take it off later. But okay, so you've got all that, and basically you're drawing a picture, and what is the output of this? What is the output of the Earth orbit? So we get to observe Earth, and then you got what, climate, etc. At the end of the day, you end up with a thing that it just looks like a brainstorming session, as opposed to an engineering diagram. But when you get to this tool right here, the Magic System of Systems Architect. That is a real sweet tool. Let me give you an example of now what you would see when you're using this kind of tool. Okay, here, this is what is called a model. So in the case of a space system, well, let me first create the model. We'll create a new project, and what is a good template to use? I'm gonna do the magic grid quick start. I can't say that I'm really good with this, but I'm gonna use the magic grid, and I'm gonna call it the space system of systems. I'll define what a system of systems is right now. And we got this magic grid version 2.2 template. This magic grid is a system that was created by I think one of the authors, his name is Aurelius Markovich or something like that. And he's written several documents on how to use this. It's a really nice thing because it's a framework. It's not just it's not just another template. It's actually a framework for using the SysML language. The SysML language is like UML. UML being the Unified Modeling Language. SysML it's not just for software. It's also for systems. So let's go ahead and create this magic grid. I'm not gonna use the whole item to architect it, but just to show you what the space system would look with SysML. Okay, and it's doing this thing. Remember the name, Magic System of Systems Architect. And notice how it already pre-populated the model. It put me a bunch of stuff. Normally, when you use pure SysML, you do not have this template. You have to design your own stuff. And in the engineering world, to become a good engineer, you have to know what other engineers did, and when it's good stuff, you must use it, unless you can build something better and more efficient. But reinventing the wheel is not something that an engineer should be doing. So in looking at this template, they got these the problem domain, the black box perspective, the white box perspective. Here I'm not even sure which one to use for the orbital regimes, because we're dealing with a system of systems, but what is the system of interest? So I guess we're gonna go into a white box perspective, and actually no, let's continue with the black box, since we're gonna create a use case diagram instead of an internal block diagram. Just bear with me for a while, because you will see all that I'm talking about right now, and these are everything that I'm mentioning right now falls under systems engineering, specializing in model-based systems engineering. So let me go and create a diagram, and here we have a SysML use case diagram. Okay, and let me go back to that screen where I created the this thing. This is actually this you cannot turn in. You would have to draw it in some thing, but it's not actually a model. It is static. It's not dynamic. It can't be updated. You can't really configuration manage it. Well, you can, but it's just a nightmare. It's not necessary when there are better tools right now. But when you look at this, let's call this the use case, okay? We'll call it orbital regimes use case. Orbital regimes use case. Okay, and when I say an orbital regime, basically it just means how far up in space a satellite goes. When you're there are I'm not gonna go into orbital mechanics right now, but basically the moon is an example of an item in orbit. It doesn't need any gas. It just uses the gravity that is between the Earth and itself to keep orbiting around the Earth. The same with the sun. All the planets are in a solar orbit around the sun. So in Earth, you got the low Earth orbit, the medium Earth orbit, and other orbits, like the polar orbit, or etc. But you get the picture, I hope. Let's go and put a use case. So this item here, now we place it in a model, and this model we can name it. We'll call it. We have to use a verb. Well, we don't have to, but I believe that we have to use a verb when we're modeling. So we'll call it orbiting. Orbiting. Let's say where we're orbiting. We're orbiting Earth. Orbiting Earth, okay? So to orbit Earth, you must be in one of the Earth regimes. Otherwise, you're using a powered vehicle, which in this case, our main power is gravity. And the actors that are going on here, you could use this guy, but well, let's make let's choose a external system here, and we'll call this system space vehicles, right? Space vehicle. And this here would be an input to the Earth orbit. And then who's inside the Earth's vehicle? You got some actors. Let's see. Let's use this guy here. So this guy would be I guess an astronaut. I wonder if that's the right relationship. Anyway, but you could see that it's got a special sign of what's going on in there, and maybe we got other external systems inside the space vehicle. For instance, a payload. Oh, this ugly thing. Let's go back to this one. And inside the space payload, what is carried off into space? Let's one instance of things carried off into space would be the CubeSat. And I guess satellites. But notice that the purpose of taking a CubeSat is that it's going to orbit right. Once it's deployed, it's going to be orbiting Earth, and the I guess this relationship isn't necessary because it is a derived relationship. So I'm gonna delete this thing if I can figure out how to delete it. The nice thing about this is that it deletes it from the model too. It asks you first, would you like to delete association from the model? Yes. So you see our model? So now you got all these items inside your model. And so we got one system that interacts with or that is an input. Let's put some other systems. I don't like that satellites is derived from here because, well, actually I'm gonna make a relationship between satellites and orbiting Earth because that does orbit Earth, but not all satellites orbit Earth. Like for instance, let's put the James Webb Telescope in there. James Webb Telescope. I wouldn't consider that a satellite. That's more like a space probe. But it was at one point a payload for a space vehicle. And that relationship is wrong. So I'm going to delete it. And there we got it. Okay. So the James Webb is going to go into deep space and do its thing. So we got this item that is explaining what is happening when you launch a space vehicle. You put a payload. Sometimes it deploys CubeSats. Some of the CubeSats, well, I'm imagining that all the CubeSats orbit Earth. I'm imagining that some of them, I guess, get placed into, they go into oblivion. But let's put them here. And satellites orbit Earth. And well, CubeSats is a subset of satellites. So let's go ahead and delete this relationship. Do you notice how simple it is to fix the drawing? And there are more benefits that I'm not gonna go into it because this software is big. It can be used to create projects that span billions of dollars, maybe and then spend decades with hundreds or thousands of engineers all working together to materialize a system. It's a good software. So we got this item here so far, and there's other stuff that is in here. One of the items one of the systems that is not good, that is actually quite dangerous, especially for astronauts, is space debris. There is a movie by Sandra Bullock on the Kessler syndrome. The Kessler syndrome is what happens if we don't clean up space. So let me first make the relationship. Space debris is in orbit. Space debris is a special kind of orbital element. It is not an asteroid. It is nothing natural. It is leftover equipment or material from items that humans launched into space. Well, for example, one example of space debris would be spent rocket stages. Before Elon Musk, or maybe like in the 1950s or when it started, it was cheaper to dispose of the spent rocket stages. and leave them in space. So that is one form of space debris. Another one would be what else would be how about the decommissioned satellites? So let's put this. They get placed into an orbit also, known as a graveyard. So these are called decommissioned satellites. Actually, yeah, these fall under space let's put them under space debris because they're still in space and they're not operational. Anything that is no longer, I guess, used, that no longer has an operational purpose in space, we'll classify it as space debris. Decommissioned space debris. Look at the name, decommissioned space debris. But the nice thing about a model is that you can easily change the name. So I think if I change it here, it will automatically change everywhere in the model. Decommissioned, we'll call it satellites. See how it changed it? And this is oh no. If I do Control Z, will it take off that extractor? Yes. Okay, so we got decommissioned satellites. So this is our model of space orbit right now, using the Magic System of Systems Architect software. You gotta admit, this is fun. Not every a lot of projects, I guess, there's a lot of work involved, but for some reason I find this software really fun. Compared to coding is like solving puzzles, but this, you're actually like drawing a picture so that other people can understand it. Whereas when you're doing computer programming, you're actually writing code, telling the central processing unit what to do with the data and all the information that you're providing it. Whereas with this software, you're actually drawing out a system. This one's a nice system because you're actually, this is called the use case. There are several types of different diagrams. Okay, so now we see that some of the uses for orbiting Earth. Now let's derive some of the benefits from orbiting Earth. Like what are we doing when we orbit Earth? How about one example is observing the Earth. There's a lot of Earth up. I'm gonna put observing the Earth, okay? Observing Earth. I like to use verbs. I'm not sure if it's required for the use case, but I'm using the verbs because it is an action, and this is a subset of orbiting Earth. I like this thing because it lets you draw real fancy stuff with it. Take a look at this, and you can play with those, making the arrows as pretty as you want. Anyway, why would we observe Earth? There are several reasons to observe Earth. For one of the main ones, let's put another use case that derives from here, would be how about storm tracking, weather tracking, tracking clouds. Let's just categorize it under weather awareness. Okay, so we got weather awareness for tracking, for observing the Earth. What would be another good reason? What would be another good reason for observing the Earth? How about what about well, I didn't put a verb there. This isn't good practice. We're gonna need to rename that thing. Let's go to the model. If anybody asks you if you've done model-based systems engineering, you can tell them that you've used Magic System of Systems Architect, and that you've done use cases, but and that you've done the use case diagram, but like this weather awareness, it's not good because it doesn't have a verb. Let's say gathering weather data instead. We'll rename it at the model level. Gathering weather. We'll say data. Gathering weather data. Okay, so now you got weather data right there. Now let's go ahead and what would be another reason to observe Earth? There are about military surveillance. We'll call this tracking terrorists. Okay, so when you I don't know what the right word for this would be. I don't know if it's spying or maybe spying would be more like military surveillance. No. I'm gonna rename it here just so that you see that when we name it here, it's gonna rename on the model. You can rename it from anywhere. So we will call this military spying. Spying. And I'll put a little note like military surveillance. Military surveillance. I don't know how to spell. Maybe this thing has a spell checker. Surveillance. Wow, it's got a spell checker. And this is a reason for observing the Earth. And gathering weather data, spying. Okay, let's move on. What it would be another reason for orbiting the Earth? One of the reasons that we can send probes into deep space is because Earth, what is it called? Orbital mechanics or orbital dynamics? I forgot what it's called. There's a science to it. But what it does is you launch a rocket and then you put it into orbit, and once it's in orbit at a certain point, you get catapulted into deep space. So let's include a use case that says space exploration. There was recently a really cool mission. It was a commercial mission that launched some astronauts onto the polar orbit. What that means is that the I think it was a Dragon that went up there. Elon Musk's SpaceX rented out their equipment to some commercial company, and they put some astronauts on a polar orbit. This orbit here, it goes from the North Pole to the South Pole. Imagine that. It's going through the North Pole to the South Pole, and imagine that as it's orbiting, the Earth underneath them is spinning. So they were basically scanning the Earth. So that would fall under Earth observation. I don't know why you would need to. I guess we could put it under uh, Earth imaging. I'm not sure if that's a category, but let's just put it, since we're just exploring here. We're creating our model. We can always change it. Earth imaging. And here we this is another reason to observe the Earth. So we got exploration. What about communications? Um, when I'm thinking of communications, you got the satellite phones. You got satellite TV. Let's just put a big category here for communications. We're running out of space here. But these communication satellites have a good reason to orbit the Earth. One good reason to orbit one. The dog's barking outside. I'm sorry if you hear some noise right now. Hopefully nobody interrupts my video. Anyway, but we got communication satellites, and why do they need to orbit the Earth? Well, if you are in a part of the Earth where you don't have a landline, and there are not antennas to pick up your cell phone, then you gotta use a satellite. And when you make your call, the call hits maybe one of Elon Musk Starlink satellites, and then it does its thing, relaying the message till it could reach whatever phone you wanna gather. There's also the Iridium. There's several communication satellites. There's also I think DirecTV would be an example. Would be an example of satellite communication. Also, you got like the communication from the space agencies that have their satellites so that they can monitor their deep space equipment. Like when it's in deep space, it's gotta send a message down toward the Earth, and the communication satellites catch them, and then it relates it down to the Earth. So let's fit a couple more, and then we'll be done with this video. You'll already see how modeling is done, and see if you would wanna become an architect. This is not just for this is an advanced tool, system of systems architect, but there is an MBSE, but it's a whole discipline that falls under the under model-based systems engineering. But let me just finish off by when we say communication satellites, we'll put here like what's another internet, fast internet. Not all internet goes through the internet, but there's some of it. Fast internet. What about a ship? There could be like a ship in the ocean. So let's put that. We can put ships. We'll put the verb. I forgot that I was doing this. Link ship communication. They might need a satellite. They could use it. They might have other means, but they could use a satellite. So we got fast internet. We forgot to put TV. So let's put satellite. We're running out of space here. We'll put a satellite TV. Okay, and we forgot one of them, satellite phone. And remember, we could make these arrows customizable so that we can fit more stuff. And let's put our satellite phone there, and then we'll turn this into our boss. And if we're lucky, we can present it to a whole team, since we will be the architect of the system. And we can tell them, okay, so this is the system that we have. This is our analysis. We got this, we got that, and these are the players, these are the actors. This is actually what they're called. Notice these systems here, the little boxes, they're called actors. There's different types of things, and these other ones, these little ellipses or ovals, they're called use cases. And these empty arrows, I think they're called derived relationships, or no, they're called generalizations. But I think they're basically derived relationships. And it's got a specific format. Look at the naming convention. So if you ever want to look at any of this stuff, look up books on SysML. That's the first thing that you gotta look. Get some books on SysML, and this Magic System of Systems Architect software. You can download it, and I think they give you maybe like a week or a month trial before you purchase it. I would imagine it costs a lot of money, but also one of the best sources for this would be in COSI. I forgot what in COSI means. International Council on Systems Engineering, and they have like a bunch of documents that talks about modeling. And not to mention, this is the cool part of systems engineering. But before that, you would have to go and learn about learn the introduction to it, which is what is it? Stakeholder analysis, system analysis, requirements gathering. It's a really cool engineering discipline. But you do need to have some experience in engineering. I mean, sure, you can go directly into an engineer, but how much will you know? How much will you have experience? It will be good experience if you get into it, because there's so many projects to look at. Anyways, if you lasted through all this, we'll go ahead and save this once more. And I'm gonna thank you for staying with me on this video.